Hi there. We're going to start talking about using synthetic division to help us factor polynomials that we don't know how to factor any other way. And so just a quick tour of the type of factoring you've learned. If you go back to like the beginning of Algebra 1, you learn types of factoring where you take out the greatest common factor. So like if I give you something like this and I ask you to factor it, you'd say, oh, okay, what goes into both of these terms? Well, 3 goes into both of those, so I can take out a 3, and then x is common to both of them, so I can take out an x, and then what's left is x minus 2. So that's factored, right? Taking out the greatest common factor. Another way you learn to factor later on will be factored binomials. So if I gave you x squared minus 5x plus 6, you would say, oh, okay, well, I can't take out a greatest common factor, but that doesn't mean it can't be factored. It might be one of these where it breaks up into two binomials here. So I need numbers that multiply to 6 and add to negative 5, and I think a negative 3 and a negative 2 will do it. Right, so there's another type of factoring. Later, I'm going to show you a type of factoring called factoring by grouping. But for now, let's take a look at this polynomial here. We clearly can't take out a greatest common factor, right? Because there's no number common to all of them other than 1. And these three terms have x's in them, but this one doesn't. So we can't do the first way either. So what do? Well, what we need to do is find one of the zeros of this function on our calculator, and that is going to help us to break this down into the factors. So notice that the reason getting a 0 is useful is because, like, look at this polynomial over here. What are the zeros of this polynomial? If I asked you that question, you'd factor it, and then you'd look at the two factors and say, oh, well, when I plug in 2, I get 0, and when I plug in 3, I get 0. So the zeros are 2 and 3. We can use that reasoning in the reverse too, because if I find one of the zeros of this polynomial, then I know one of the factors. Right? For instance, like if I put this in the calculator, if I didn't know how to factor, I put this in the calculator though, and I found that 2 was a 0, I'd go, oh, okay, x minus 2 is a factor, and I'd write down x minus 2 times, and then I'd have to go figure out what the other factor was. So we're going to do that now. So I put it in the calculator. I put the function in the calculator. The appropriate window, we'll see how this one does. I only need to just find one 0. So I got 3 zeros here, but I only need to find 1. So let's calculate this one right here, figure out what it is. It looks like it's 1, but you never know. Sometimes calculators can be deceiving. So I'm going to go to the left, press enter, to the right. So it's true, 1 was a 0. So now I know that 1 is a 0 of this function, of this polynomial. So what that means is I can write this as x minus 1 times, and now I don't know what I have to times it by. That's what I got to figure out. But once we know 1 is a 0, again, it's like doing this reasoning in the reverse. If you know 2 is a 0, then x minus 2 is a factor. If 1 is a 0, then x minus 1 is a factor. So the question is, how do we get the rest of it, right? What do I have to multiply x minus 1 by to get this guy back? Well, we're in a no different a situation than if I just say, if I learn that 10 equals 5 times something, right? How would I figure out what that something was? Well, I would do 10 divided by 5, right? And I would get my answer. So we're going to do that here. We're going to do x cubed minus 3x squared minus 13x plus 15, or f of x, same thing, divided by x minus 1, right? This is like the 5 over here. We're going to divide this by x minus 1, and the answer is going to tell us what we would have had to multiply by x minus 1 by to get the polynomial. So now we have to face this division. Well, this division might seem like a pain, but because we're dividing by a degree 1 polynomial, x minus 1, we can use synthetic division. So this is a refresher for you, because I know you saw it in Algebra 2, how synthetic division works. So the 0 associated with the factor x minus 1 is a 1, so I'm going to put a 1 in the box. And when I write the coefficients of my polynomial in order, and then the process works like this. You bring down that first number, and then you do a process of multiplying and adding, multiplying, adding. So 1 times 1 is a 1. Now we add. Negative 2 times 1 is a negative 2. And then you add. Negative 15 times 1 is a negative 15. And then you add. And again, this is our remainder. Notice that it makes sense that our remainder is 0 because we just found that 1 is a 0 of this, which means the factor x minus 1 has to go into this evenly without any remainders. Now let's decode this. 1 minus 2 minus 15, well that's, right, this here was like the x cubed coefficient, right? But when you divide by this x to the 1 power, that means that your remaining polynomial is a degree 2. So this here decodes to x squared minus 2x minus 15. So that's what goes here. Alright, so that's how synthetic division is used to help you factor. If you know one of the zeros, you can use that synthetic division to break down your polynomial. And now what do we do? Well, it's very possible that we're done now. Like, it could be possible that this piece doesn't factor, right? Maybe it just doesn't factor and we're done. We factored as much as we could. But in this case, I think this does factor. If you look closely, I think it does. So to continue, we're going to write down x minus 1. That comes down. X squared minus 2x minus 15 is equal to so you need a 5 and a 3, and the bigger number is negative. And now we're surely done, right? We needed a factor, and we did. So notice we didn't, it kind of combined a lot of skills here. We didn't really just, it wasn't take out a greatest common factor type. It wasn't exactly this either until we got to this piece right here. But to get the ball rolling, we had to find one of the zeros. Okay, and what's key to remember is that when you find a 0, you know one of the factors, right? 1 was a 0, so the x minus 1 was a factor. Maybe we didn't have to use 1. If you go back to the calculator, maybe we could have found the 0, 5, because it looks like 5 is a 0 too. That's a 5. That's a 0 over 5. If we had done that, then we would have put an x minus 5 here. We would have done the synthetic division, and we would have gotten x minus 1 times x plus 3, all, that multiplication result here, and then we would have factored that. Okay, but the key is once you know a 0, you know a factor, and you can use synthetic division to get the other ones.